In this video we're going to be looking at the Hertzsprung-Russell diagrams, and this is chapter 13.3 in your textbook. So what is the Hertzsprung-Russell diagram? Well, it shows us the relationship between luminosity and surface temperature and colour. It was discovered independently by two scientists, Hertzsprung and Russell, and it plots luminosity against surface temperature and colour for stars. Here's an example of some stars plotted on the Hertzsprung-Russell diagram, and you can see that luminosity appears on our y-axis here, and surface temperature in Kelvin appears on the x-axis here. Note the dependent and independent variables. So, features of the HR diagram. Well, the majority of stars are found along a slightly curved diagonal band, and these are what are known as the main sequence stars. The upper end of the band represents hot stars that are up to 1 million times more massive than our own Sun. The lower end of the band represents the cool stars that are as little as 1,000th the luminosity of the Sun and 1/100th the mass. Further features. Above the main sequence and to the right are the giants, which are cool and luminous. They're 100 times more luminous than the Sun due to their size. There are two groups of these, the red giants and supergiants. Below the main sequence and to the left are the white dwarfs. These are exceptionally small stars that are white hot and have very low luminosity. These types of stars are quite unusual. Now here's a version of the Hertzsprung-Russell diagram, and we see on the left absolute magnitude. Absolute magnitude being the scale on which we place all stars in comparison to the brightness of Vega. There are many versions of the Hertzsprung-Russell diagram available, and some of them are in colour, which gives us an idea of the surface temperature in relationship to colour. And here we have the band of main sequence stars here, and obviously our giants and supergiants up here, and our white dwarfs down here. Our own Sun is somewhere around about here on the Hertzsprung-Russell diagram. Here we see another version which gives us some idea in terms of size by putting in a picture of the stars as spheres. And here we see the main sequence stars, and as we said before, our own Sun is around about here. Here we have the surface temperature in Kelvin, and note that increasing temperature goes in this direction and decreasing temperature goes in this direction. One more look at our stars. We've just showing some of the main sequence stars that are larger up here, and some of the smaller ones, more similar to our Sun, are here. And of course we've got luminosity, and this time we've got absolute magnitude over here. Now absolute magnitude is a logarithmic scale describing luminosity, and this is important for us to know because it shows the luminosity of each star. And one final version. We have absolute magnitude again, and instead of showing the stars separately, we've just got the bands being shown here. And we'll see Procyon, which we've come across before, and Sirius down here are actually in the white dwarfs group. And Antares and Betelgeuse are up here, which we also noted earlier in a previous video. And here is our own Sun in the main sequence stars. And our own Sun is about halfway through its lifetime. And again, we've got another diagrammatical representation, again with our luminosity on this scale here, and our surface temperature decreasing from left to right here. So, generally speaking, less massive stars are cooler and duller, more massive stars are hotter and brighter.